Hello, so today we are going to do this week's contest problems. So the second problem is increment submatrices by 1. So what we have here is we have an n by n zero indexed integer matrix that is filled with zeros, and we are given a 2D integer array query that has two things: the coordinates of the first position and the coordinate of the second, and what those represent is basically the you can think of it as a rectangle like this, right? The boundaries of the rectangle, the top left and the top right corner. Okay, so that's what we get a matrix, and then we get queries with these two coordinates, the top left and the bottom right. And what we want to do is we want to add 1 to every element of this submatrix that we get in each query. We want to add 1 to it. So, and then what we want to return at the end is the matrix result after applying all of the queries. And the matrix starts out with all zeros. So for example, here n equal to 3, that means we have a 3 by 3 matrix, and initially all the values are 0. The first query says we want to fill out we want to add 1 to the submatrix starting from 1 1 ending at 2 2. So 1 1 is this position, 2 2 is this position, and so we fill that submatrix with the first one as its top left and the second one as its bottom right. We fill that one with 1. Then the second query tells us to add 1 for the submatrix from 0 0 to 1 1. So 0 0 is this position, 1 1 is this position, and so we add 1 to each of them, right? So they all become 1. This one had already a value of 1, so when we add 1 we have 2 here, right? And so the result matrix after applying all of these queries is this one, and that's what we return here. Okay, so that's the idea. Now let's see how we can solve it. If you look at the constraint here, we have n is up to 500. So the matrix itself is 500 by 500, so it's 5 and then 10 to the power of 4, right? So you can think of it as 10 to the power of 4, and then the queries can be 10 to the power of 4. So you can see here we can do something that is O of n squared, which is if we want to traverse the entire matrix or set the entire matrix, and the by queries, right? So if we do something like a brute force where we'll just go through the queries and add 1, that won't pass because it would be 10 to the power of 4 by 10 to the power of 4, which is 10 to the power of 8, and then multiplied by 5. So that clearly won't pass. We'll get time limit exception. So let's see how we can solve it. So what is the brute force approach that won't work? So the brute force approach is, let's say this is the first coordinate, so R1, let's call it C1, and this one is R2, C2, right? So what we want is we want the submatrix, right? In our matrix, this would be R1, C1, and this would be R2, C2. If we're going to do it in a brute force way, let's say this is something like this, then we would have to add 1 on each one of them, right? Right? And then we will go to and do that for the second query. What is the worst case scenario? The worst case scenario is that each query is from 0 0 to n, and maybe we have a lot of queries 10 to the power of 4 or something, right? Then that, and maybe n here is, let's say, maybe I don't know, 500, right? So if n is 500 and the number of queries is 10 to the power of 4, then we'll have to do 10 to the power of 4 times by 500 by 500, right? Because we would have to add 1 for each query. We'd have to add 1 for each cell, and the number of overall cell is n by n, right? So you can see that gets pretty big. This is a huge. So we can't do it. So how do we do it then? So just by intuition, what do we want to do? So we can have multiple queries. What we want is not to go through all the queries, right? And so the main thing is, how do we condense these queries in a way where we don't need to go through them all. For each of them, set the ones, right? So that's sort of the idea. And if you think about these queries, if it was, let's say, an array, what would this be like? If it wasn't a matrix, if it was an array, maybe we get just a position like this, and then this position, and then maybe we want to update this subarrays with 1, and let's say we had another position, 2 positions that we want to update this one, and maybe we had something like this, we want to update this one. What is this? What does this look like, right? This actually looks pretty much like intervals, right? Because the first interval would be this one, the second interval would be this one, and the third interval would be this one. And so instead of, if it was like this with a single array, instead of doing each interval separately, doing this one first, maybe, and then doing the second one, and then doing this one, instead of doing that, we just want to know for each place how much we want to add. So we know in this portion, right, in this portion here, let me grab a different color to make it easier to see. So we know that for this portion here, we want to just add 1. For this portion here, because there are 2, we want to add 2. For this portion is just 1. For this portion, up until here, it's 2. But from here, it's 1, right? So what does this look like, actually? This looks pretty much like line sweep on a set of intervals. I have a video that I will link explaining how to do line sweep that you can take a look at if you don't know how to do it, but roughly the idea of line sweep on intervals is this. So we have these 2 intervals. Let's say we have these intervals like this. Every time we encounter the beginning of the interval, we add something. And since here we want to add 1, let's add 1. And every time we encounter on the end of an interval, we subtract 1. Why? Just after the end of the interval, so at the end of +1, we want to subtract 1. Why do we want to do that? Because, so here we had 2. But here we should subtract 1 because this interval ended. We don't want to include it anymore. So here, starting from after, just the moment after the end, we want to remove this interval. So we want to subtract 1. So that's the idea. And so if we do that here in this case, that would mean here we have +1. Here we have -1, +1, -1, +1, -1. So what does, if we take the accumulative sum at each moment, here we have 1. As soon as we start here, we have 2. As soon as we get after this one, we have -1, so we have only 1. And then when we get here, we get another +1, so we have 2. And then when we get here, right, from this one, now we have 1. And then when we get here, after here, we have 0, right? And so what this tells us, if we had an array, is basically, once we do all of this updating, right, we can create some sort of a prefix sum, right? So what would be this look like? So we'd have 1, and then when it changes here, we have 2, and then when it changes here, -1, we have 1, and then when it changes here, we have just 1. We already did that one. And then when it changes again, +1, so we have 2, and then when we get -1, we have 1, and then we have 0. And so this would be actually the final array, because that's all there is. Instead of so this would be our array, and this would be the final one. So using a prefix sum on top of the sweep line. So sweep line plus prefix sum, right? And sweep line would be linear because we would just go when we encounter an interval, we add +1. When we encounter the end, we add -1, +1, and we do that for the intervals in sorted orders. And so here, if we do this, then we have the final array in a linear time here. We didn't have to do each query independently. We sort of condensed the queries into this array. And so now that we know how to do it with a 1D array, we can just translate that and apply it to a 2D matrix that we have, right? Except there are a couple of caveats for the matrix. So let's take a look at what that look like. So for the matrix, what we have something like this, right? And we have multiple queries. So similarly here at the start, we want to add +1. So what is the start? The start is the top left, So this is the start. So at the top left, we want to add 1, right? Because the problem wants us to add 1. So, and similar like we did here with the intervals for line sweep. But, so here we add +1. And we'll do prefix sum so that it's added all the way, right? Similar to what we did here. But when we reach after the end, which is here in the second in this column position, which is, let's say, so this would be C2, this would be C2 plus 1. At C2 plus 1, we should subtract, right, to remove this +1 because the submatrix ended. So here we need -1. So basically what this would mean, the top left is R1, C1. So at the top left, we want to add +1. But after we get out, which is R1 but C2 plus 1, so this is C2, we want to do -1 so that we cancel out this one here, right? And now what should be after this one here? So this was, let's say this one is R1, this one is R2, this one is C1. So what should be for R2, C1? +1, right? For all of these here, we'll add +1, but we'll do that with prefix sum, right? We'll just, for each one, add the previous row value and the previous column value. So that will cover the values in between here. But for this last one here, just after the end, we want to do similarly to what we did here, right? Because we don't want to calculate these because they are not part of the submatrix. So for that one, we want to subtract -1, right? Okay. And now the problem becomes, what about for this one here as well? Because we also don't want to take into account this portion and this portion, right? We want to cancel them out and remove them. But the thing is, since we'll do prefix sum, it would be like we had -1s, -1s, -1s until the last one. And similarly, with this column, we had -1, -1, -1, -1, right? So you can see this position here actually will have -1 twice. One is coming from here because of the prefix sum, and one is coming from the prefix sum on this row, and the other one is coming from the prefix sum on this column, right? And so what we want is we actually want to add 1 so that we can cancel out one of these -1s. We only need 1, right, to cancel out the +1. And so this means that here, what is this position? This position is R2 plus 1. Sorry, that's what I should had. Yeah, it's R2 plus 1, C2 plus 1 here. So we want to add 1 to cancel out the double subtraction. Yeah, sorry, here it's actually, just let me fix this here. So this is, what is the position for this here? It's row 2 plus 1, right? Remember, this is the row after the end. And what is the column? It's just C1, right? That's the column. Yeah, this column here is just C1. So this is R2 plus 1, C1. And that's pretty much it in terms of, so once we set these, think of them as the intervals end and start, but applied in a 2D way to a submatrix. So we'll do that first. Now we'll do the same thing we did here with the prefix sum. So what would that look like? Let's apply it to our first example. So 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's our first example here. Now the queries are, the first one is, 1, 1, 2, 2, and the second one is 0, 0, 1, 1. Okay, so let's apply these. So the first one, 1, 1, so that's here. What do we would add 1, right, to R1, C1. So here we would have 1 plus 1, right? And then for R1, C2 plus 1, well, it's out of boundary, so when it's out of bounds, we don't need to add anything. Yeah, but maybe let's have n equal to 4 just to make this more interesting, because otherwise we won't have, okay, so this would mean here we have 0, 0, 0, 0, 0, 0, 0. Okay, so for n equal to 4. So what would be our R1 C2 plus 1? That would be 1. So this would be R1 C1 R2 C2. So R1 C2 plus 1, that would be 1. C2 would be 3. So 1 3. So this is 0 1 2 3 0 1 2 3. So position 1 3, that would be this one here, right? So here we want to do -1 to mark the end of our the thing that we have here, the submatrix that we want to add 1 to. And now what we'll do is we will go to this one as well, the second one, which is, so we did this one, we did this one. This one is R2 plus 1 C1. What is R2 plus 1? That's 3. What is C1? C1 is 1. So 3 1 is this one here. 1 is this here. So this would need to be -1. So you can see this is the row after the matrix. So this is the submatrix we are trying to fill. And so this is the row after it, the column after it. The last one is R2, is this one, which is R2 plus 1, which is 3, C2 plus 1, which is 3. So this is the one that we will end up setting twice from this column with the -1 in the prefix and from this row. And so we want to just add 1 to not double subtract, okay? So that's the first step. Now for the first query, now let's do it for the second. And you can see this is not open. We update only 4 positions. So that's what makes it more efficient. Now for the second query, we would have R1, C1, R2, C2, right? And so we want to fill R1, C1, which is 0, 0 with 1. And so we have 1 here. Okay, that's the starting position. And now we will fill this here, which is R1, which is 0, and C2 plus 1, which is 2. So we'll fill 0, 2, which is here with 1 as well, with -1, sorry. And you can see this makes sense because this is the submatrix from this query, and so we are doing -1 so that we can stop the prefix sum, right? So that we can stop adding ones. And then for the second one is this one here, which is R2 plus 1 C1, which would tell us it's 2, and C1 is 0, right? So 2 0, that's this position here, and so there we want to do -1, right? And so again, this makes sense because this is the submatrix we are trying to update. And then the last one would be this one here, which is R2 plus 1 C2 plus 1, which tell us it's 2 2. And so that's which position? 2 2, that's here. We want to do +1 because we will end up doing a prefix sum and updating with -1 from this here, right? And we'll do it from this here. So we want to cancel out one of them so that we don't double subtract. Again, same reason. Okay, so once we have this, again, here we updated only 4 for these queries, only 4 places. So it's constant. And then now we'll do the prefix sum for each row and each column. So what would that look like? So that would be here. Let me actually do it in a separate place just so that this is more clear. So we have 4 positions. Okay, 0, 1, 2, 3, 0, 1, 2, 3. So here we had 1, 0, -1, 0, 1, 0, -1, -1, 0, 1, 0, 0, -1, 0, 1. Okay, so let's do the prefix sum updates. So we have 1. That means here we have, so each column will be the previous column. So basically each column position would be the previous column will be added to it. Okay, and so 1 minus 1, that tells us this is 0 now, right? And that's exactly what we want. We wanted to only fill out this and cancel out the rest. And so this one, the previous one plus itself was 0, so it's 0. And then here 0. Here we are doing the rows. We'll do the columns later. So 0, we leave it as it is. 1 plus 0, that's 0. 1 plus 0, that's 1. And then here 1 plus minus 1, that's 0. Okay, and now here at this minus 1 plus 0, that's minus 1. Minus 1 plus 1, that's 0. And then here stays 0. Let me just make sure we update each time. And then here 0 plus minus 1. 0 plus 0 is 0. 0 plus minus 1, that's minus 1. Minus 1 plus 0, minus 1 here. Minus 1 plus 1, 0. And now we do the columns. So when we do the columns, 1 plus 0, this one stays as it is. 1 plus 0, that's 1. Here it cancels out to 0. And here it stays 0. 1 plus 1, 2. 2 plus minus 1, that's 1. 1 plus minus 1, that's 0. 0 plus 1, 1. 1 here. And then here we end up with 0. And then these will end up with 0. So you can see exactly what we wanted to happen happened. We updated this submatrix with 1, 1. And this submatrix with 1, 1. And this one ended with 2 because it was updated as part of this query and as part of this query, right? I hope that was clear. So once we do the prefix sums, that's it. We have the array. So we did the prefix sums. Basically, it means that for every I and j, we'll do basically, let's say this is the matrix. We'll do mij is plus the previous row, which is I minus 1j. And then we'll do the same thing on the column side as well, because we want to update for all the places, and we want to take into account the corners we did for both the row and column. And so here it would be the prefix sum on the column side, so mij would be mi. So this is each of them from 0 to n. Okay, and so here it would be ij minus 1. So that's exactly what I did here in this in the example. Okay, so that's pretty much it. And then we can return this as our matrix. So to recap, we use sweep line, but in a 2D instead of intervals that are sort of 1D. And then we use prefix sum to fill the final matrix. And this will allow us to condense queries and do them in one step with this prefix sum. And for each query, we'll just do 4 operations, which is mark the 4 edges. Yeah, so that's pretty much it. I hope this was clear. Let's write the code and make sure it passes. Okay, so let's write what we saw in the overview here. So what we said is we need to do our matrix that we are going to fill out. Let's first just initialize it with what we need. So it's an n by n matrix. So that would be, this is 4 in range of n. And then we want to just go through queries and just place the 4 edges. So we have R1, C1, R2, C2, and this is in queries, right? And so what we want is just the 4 edges. We said R1, C1 is going to be just, we want to, so this is the top left. So this is top left corner. And so we want to add 1, right? And then we have, this is the bottom left, and then we need to update the top right and then bottom right. Okay, so what for the bottom left, what do we want to do? We want to have let's actually do the top right first. So the top right, top is m of r1 plus 1, right? C2 it's actually the same row, but it's the last column plus 1. So this one is the top right one that we want to decrement by 1 because it's the end of the submatrix that we want to add 1 to. And then for the bottom right, there we also want to do, so actually let's do the bottom left. Bottom left we want to do -1, right? Because it's the end of the column going down that we fill with 1 from this here with prefix. And so what we want, what would that be? So it's the bottom left. So it's row 2 plus 1, right? So that would go down 1 step, and it's the first column, right? So we want to cancel the column, the left column. We want to cancel the rest of the prefix. So that's why we would do -1. And here we want to cancel the prefix for the row, for the column. For the column with this -1. And so the bottom right though, because from these two we'll subtract twice, so we want to add 1, so we cancel one of them. And so that one is M. Bottom right is row 1 plus 1. Bottom right is row 2 plus 1, C2 plus 1, right? And then we want to add 1 to cancel one of them. So that's the idea. You can go back to the overview, and if you didn't quite get these indices. Now the only thing we need to take care of is what if this is out of bounds, right? Let's say maybe R2C2 was at one of the edges of the matrix. So we just want to safeguard against that, because if it's beyond the boundaries, we don't need to care about it. So we want to make sure it's smaller than n. Similarly, we want to do it every time we add 1. We want to do it, and so we do it here, and then here we want to do it also for both, because we add 1 for both. So +1 needs to be smaller than n for this to work, and C2 plus 1 needs to be smaller than n. Okay, and now we do the prefix sum to, now that we recorded each query, we do the prefix sum that will give us the matrix we want. So first we want to do the prefix sum on rows, and then we'll do it on columns. Okay, so the prefix sum on rows, we want to go for, since it's on rows, we want to start from 1, because the previous one, the first one doesn't have anything before it to add to it. And then we want to do it for each row, so we want to go through the columns, and what this would mean is basically that for each row we want to add the previous row values. And we want to do a similar thing for the prefix sum for the columns. So that would be 4i in range of n, and j, we want to start from 1 because the first column doesn't have anything before it to add itself to. So similar reason there. And we want to add for each column, we want to add the previous column, so j plus m of I of j minus 1. And at the end we want to return the matrix m, right? So that's the idea. Now let's submit this. And this passes our test cases, right? Yeah, so that's pretty much the idea here. Now, if you take a look here, we are doing O of queries here by 4 each time, so constant. The content itself is constant. And then here we are doing O of n squared. And then here we are doing O of n squared as well. And you can see the problem says n is up to 500. And so the bigger term would be q. So you could either say it's O of, in terms of time complexity, is actually O of q plus n squared, but q here is the dominant term. Yeah, so that's pretty much it. Please like and subscribe, and see you on the next one.